Okay, so we're back for day 4. So we learned about decay and depreciation and growth and appreciation in the last one. You learned about compounding interest and semi-annual and all that good stuff. So we're going to kind of build off that into what is known as continuous compounding interest. And that's when we're going to get into the base E, which we haven't talked about a ton, but you saw it a little bit on day 1. So basically, the more frequently that something compounds, the more money that you're going to make, obviously. So semi-annually versus quarterly, monthly, so on and so forth, you're going to make more and more if it's compounding more often. So it says, suppose you invest $1 at an annual interest rate of $100. How much would you make annually, semi-annually, so on and so forth? So instead of answering those questions up there, we're going to answer them down here. So this would be annually, semi-annually, then you would have quarterly, then you would have monthly, then daily, and then you have to figure out the other ones. So if we know that daily is equal to 365 times, and then if we were going to say hourly, well, there's 24 hours in a day, so 365 times 24, that's going to be 8,760 times it would compound. That would be your end value. If you wanted to know every minute, there's 60 minutes in every hour, so we'd multiply by 60. We'd have 525,600 would be your end value. And then finally, every second, again, multiply again. 315, 36, 0, 0, 0. So 31,536 times that it's compounding. So what would happen if you plug that in? So you plugged in this as your end value over and over and over again. Well, annually, if you invested $1 and it compounded and you got 100% back, you'd get $2. Semi-annually, you'd get $2.25. Quarterly, you'd get $2.44. So you can see you're making more money. Monthly, you would make $2.61. Then daily, you would make, I'm going to write all the decimal points out for these so you can see because they start to get really, really close to each other. So this would be daily, and then you'd have hourly would be 2.71813, and then 2.71828. And then actually minute versus second stays the same in this case, just because it's already so small. So basically what you should see is, again, the more times that something compounds, the more money that you're going to end up making. So what this happens with this is just going to end up getting rewritten, and you're going to reduce all this down to where you're going to get an E, all right? So this whole part inside is going to get reduced to kind of create that E, and you'll kind of see what that is. So E is an irrational number as n approaches infinity. We talked about E a little bit on day 1. E is the number 2.718, blah, 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 blah after that. Okay. So let's go ahead and let's graph what E would look like. So we're always going to start at 0, then we have 1, then we have 2. All right, just so we can get an idea of what that graph looks like. Anything raised to the 0 power is going to be 1. Anything raised to the 1 power is going to be itself, which I just told you is 2.718. And then if we take that 2.718 and we square that, we're going to end up getting about 7.388. So what that looks like on a graph, you have your y-intercept at 1. Then we have 1, 2.7 is about right here. And then we have 2, 7.3 is about right here. Remember, we have that asymptote at 0 because we didn't move up, down, left, or right. So your graph comes like this, and then it shoots up relatively quickly. What's your domain for everything in this whole entire unit? You should know that it's always all real numbers. Your range, okay, in this case, our asymptote again is at 0, and we're going up forever. And again, we just set our asymptotes at 0. So that's what your parent function looks like. Next part, you guys did this on day 1. So making sure that you can follow what the transformations are. We're going to do 1 in the video. We're going to do 2 in class. So if I asked you, what are the transformations? You should know that this is a reflection across the x-axis. And you should know that this is going up 5. All right, so reflection across the x-axis, we're going up 5. If we were going to make our table for this one, we can come over here. We have the point 0, 1 in that e to the x equation. We have the point 1, comma 2.7. That's a point 2.7. And we have the point 2, comma 7.4. All right, so that's your parent function. And then you have to think about what your rule is to transform. Well, reflection across the x and up 5, that means your x value is just going to stay your x value. None of those affect your x. So your x's are going to stay 0, 1, and 2. Your y values, reflection is going to cause your y to be negative, and then we're going to add 5. So if we make 1 negative, that would be -1 plus 5 is going to give us a 4. 2.7, we make that negative, and then we add on 5. So you have -2.7, and then you're adding 5, you're going to get 2.3. And then your last one, we have -7.4. We're going to add on 5, and that's going to give us -2.4. Got a little tight there, but hopefully y'all can see. Go ahead and graph where your asymptote's going to be. So we went up 5, so we know our asymptote's going to be right here. And then let's plot those points. We have 0, 4. We have 1, comma 2.3. And then we have 2, comma -2.4. So we're going to get this shape. Our domain is going to be all real numbers. Your range, it goes down forever until it hits that asymptote at 5. And then our y equals 5 is our asymptote. All right? Again, that's kind of a review of day 1. I said we'd jump into it more later, so this is us jumping in. All right, next thing that we're going to do is we're going to talk about applications, okay? This should be really, really easy. The only thing that's changing is you now have a new formula. All right? So P is your principal. That is your initial investment. So your starting value, like it's been. Your E value, that's going to be where you just plug that straight into our calculator. All right. There's even a little button for it. R is going to be your rate. All right. Again, making sure that we plug in rate as a decimal. And T is our time in years. So let's try to come down here and write what this equation would be. So $4,000 is invested. That means that this is our principal or our starting amount. At an annual rate of 6%, that's our R value. And this is the keyword that you're looking for, or keywords. Compounded continuously. That means you're using this equation versus the other equation that we learned the other day. So if we plug in, we're going to know that it's 4,000. And then E raised to your R as a decimal is 0.06. And then your T value, which is whatever they give you in the problem. All right. So if we wanted to do part B, you would plug in 4,000. E raised to your R is 0.06. Raised to your T is 5. All that goes straight into your calculator. So if you want to write it in your calculator, all right, you're going to write it like this. So you're going to start 4,000 times, and then you have an E to the X button. So your E to the X button is right here, and then we're going to plug in 0.06 times our time was 5 years. Enter, and then it's going to shoot it out for us. So we're going to end up getting $5,399.44. All right. We're going to do 4 in class tomorrow, so make sure you guys get those notes done and then get ready for day 5. All right, you guys are almost done. Doing great.